My main goal is to investigate and measure the geochemistry of the hydrothermal vent fluids and precipitates for science, but also as ground truthing for all of the in situ measurements that we'll be taking. So today I wanted to tell you a little bit about how hydrothermal vents get their chemistry. There are more than 600 hydrothermal vents in the ocean on Earth. Most of those are associated with mid-ocean spreading and plate tectonics, approximately 90% of those. The other 10% are associated with various other heat sources, but one of the most important ones is this process called serpentinization. So for mid-ocean spreading systems, we are all familiar with these black smokers, and you can imagine in the ocean, if this is the ocean, seawater gets entrained and pulled in at a mid-ocean spreading ridge, and if this is the spreading ridge itself with the hydrothermal vents here, okay, seawater at some distance away gets entrained as seawater and then circulates through the ground, through the ocean crust until it finally comes out as a hydrothermal fluid. And along this pathway, at various stages, the fluid chemistry evolves and gets reducing, gets no more oxygen is left, and also increases in concentration in sulfide and iron and other constituents that when they mix with seawater provides energy for life to exist. In a mid-ocean spreading ridge system, you have essentially a heat source. This is like a magma chamber here. Okay, and so as the fluids evolve, you also have a lot of interaction with the magma chamber here, so volatile influx as well. So sulfide gas, CO2 gas, other gases enter into the system at this point. Off-axis from the mid-ocean spreading ridge are other systems that are these serpentinizing systems that I was talking about. This is a completely different type of system because there's no magma chamber associated with that, so there's no volatile inputs, but the main driver is essentially reaction with the iron in the rocks. So it's typically it's like a weathering process, okay, and it's called serpentinization. So the iron in the rocks reacts, and you can get these small chimneys from the fluids. Small, sometimes quite large. One of the most famous ones is called the Lost City hydrothermal field, where simply the seawater is flowing through the rocks, reacting. And one of the most important things here is the production of H2 gas. Okay? This reaction with the rocks produces dihydrogen gas. And this hydrogen gas can react with for example, bicarbonate in seawater or carbon, some source of carbon in the system, to produce methane. And this can happen purely abiotically, so no biological interaction whatsoever. And so this is an abiotically formed organic compound. So this is very critical for origin of life research as a carbon source for existing life in these systems. And so the InVADER project for P-STAR will encompass all of these different types of systems, primarily focusing on black smokers associated with the Juan de Fuca Ridge at axial seamount. But we're going to target all of these systems as potential sites for ocean worlds targets on other planets and other planetary bodies.